right, welcome to our second 2.2 video. All right, we're talking about zeros of a function. Okay, so our learning targets today are going to be to find the zeros of a function. All right, we've already done domain and range. Today we're focusing on zeros. Okay, you know how to find the zeros. You may have just not have called them that before. All right, well, you probably did in your old algebra class. Zeros are the input values in which an output value of, we have an output value of 0. So if I put in 2 for x into my function, y is equal to 0. Okay, they're also referred to as the roots, solutions, or x-intercepts. Okay, it's the point, they're the points where our graph crosses the x-axis. So how do you actually find a 0? Well, algebraically, all right, algebraically, what I'm going to do, I'm going to set the function, which is usually f of x, equal to 0, and solve. Okay, so that looks like f of x equals 0, whatever your actual function is itself. Okay. To find it graphically, you look for where the graph crosses the x-axis. And as we'll talk about this later, you can use the zero function on your calculator. And I'll show you how to do that in a little bit. All right. So to find algebraically, we're going to set our function equal to 0. I'm looking at graphically, we're going to see where our graph crosses the x-axis. All right, so let's try an algebraic example here. Okay, so my function is x squared minus 3, so I'm going to set f of x, which is right here, equal to 0, and solve. All right, to solve for x, I'll add 3 to their side, so x3 equals x squared. How do you get rid of a square term? Well, you all know this. Square root both sides, so x equals the square root of 3. Now, it's not just the positive square root of 3, it's also negative, so you must write, don't forget, plus or minus. Okay? And to write our zeros, we're going to write them as ordered pairs, root 3, comma 0, and negative root 3, comma 0. Is that our answer? Yes, that's your answer right there. Boom. Fun stuff. Contain your excitement. It's hard. Me too. Samesies. Okay, so for sure. So here we go. Next one. 0 equals 3x squared plus 22x minus 16. Well, first question we should ask ourselves when factoring is what? Is there a GCF? Is there a greatest common factor here? Okay. Is there a number that goes let me try that again. Is 3 a factor of 22? Is 3 a factor of 16? No chance. All right, it is not. So what we need to do is split the middle term. Okay, now you can guess and check. If you're good at guessing and checking, then go for it. All right, some of us, that may be a struggle. So I'm going to show how to split the middle term here. Remember, I'm going to take my first number times my last. 3 times 16, I get 48. I want to find two numbers that multiply to negative 48 and add to give me positive 22. Go ahead and think of the factors of 48. Sometimes it's helpful just to write them out. Okay, I'm going to write a couple out. 1 times 48, 2 times 24, 3 times 16. Wow. What? Wait for it. Check this out. 24 and 2 seem to work. Okay, so that means I need this 22 is positive. That means the 2 has to be negative, and the 24 is going to stay positive. All right, so remember, when splitting the middle term, the only thing that changes is that middle term. It becomes 24x minus 2x. And these stay the same, minus 16. And then that's still a plus 3x squared equals 0. So now, since I have 4 terms, 2 by 2 group that. 2 by 2 grouping. All right, what's the greatest common factor that comes between 3x squared and 24x? It's 3x, and that's x plus 8. And the GCF between negative 2x and negative 16 is negative 2, and it's going to be x plus 8. That's equal to 0. Remember, these two match, x plus 8, x plus 8. All right, so I'm going to have 0 equals x plus 8 and 3x minus 2. All right. Once I'm there by that zero product property, I can set each factor equal to 0. X plus 8 equals 0. And 3x minus 2 equals 0. Wow. So x equals negative 8. And I'll write that as negative 8, comma 0. Add 2, divide by 3. X equals 2 over 3, which I'll write as 2/3, comma 0. Those are my answers. All right. Next two. Wow. First question you should ask yourself when factoring, is there a greatest common factor? There is. Not with our constants, but with our variables. I can take out an x squared, and I'll have x squared. That looks bad. Let's try that again. X squared, and I'll have 9x squared minus 16. Now, this right here, remember, there's a special name for that, all right? Difference of two perfect squares, dots problems, okay? Difference of two perfect squares. Well, since 9's a perfect square, and 16's a perfect square, and x is technically a perfect square, x times x, so the square root of 9 is 3. The square root of 16 is 4, so 3x plus 4, 3x minus 4, but you all knew that. Set each factor equal to 0. This is fun. This is so much fun. Mr. McConey, what do you do during the summer? Well, you are looking at it. X squared equals 0, 3x plus 4 equals 0, so x equals 0, x equals negative 4 over 3, and x equals 4 over 3. Ordered pairs, 0, comma 0, negative 4 over 3, comma 0, and lastly, 4 over 3, comma 0. Wow! Fun stuff. Slow down. Contain your excitement. Try to. I know you can't. All right, I sure can't. That's for sure. There's our answers. All right. Here we go. Last one for algebraically. This will be a quick one. This will be a quick one. All right, here we go. So we got 0 equals the square root of 3x plus 8. How do I get of a square root? Well, how do I get rid of a square term? I take the square root. So to get rid of a square root, I square both sides. 0 squared is 0. These go away. They're inverse operations of each other. All right, so I get 3x plus 8 equals 0. So x equals minus 8 divided by 3, negative 8 over 3. So negative 8 over 3, comma 0. Now, is that within our domain? Actually, it is, yes, because our whatever's underneath the square root has to be greater than or equal to 0. Well, this would actually, if I plug that in, I would actually get 0, which is within the domain as well. Okay, little TBT to the first video. For sure. Okay, so check it out. Here we go. Find the equations, or excuse me, find the zeros graphically. So to find the zero graphically, remember, how do we do that? Well, I look for where my graph crosses the x-axis. So here's my graph here. Looks like it crosses the x-axis here, here, and here. 3 points. That point, this point right here looks to be negative 4, comma 0. This point here looks to be negative 1. Oh, sorry, we got negative 4, 0, negative 1, 0, and it looks like this is at 2, 0. Obviously, this is a lot easier than doing it algebraically, okay? But sometimes we could also do this one algebraically as well, all right? So but I'm going to look at it graphically, okay, and kind of show you how to use that 0 function on your calculator. So I plug this in, x squared minus 4x minus 4. Make sure your zoom is at standard, number 6. All right, so you can see your graph. Okay, zoom 6. All right, so here's my function. Boom. Now it looks like this is at -1, but I don't know for sure. All right, so I'm going to hit second. Then I'm going to hit, the calc is above trace, so I'm going to hit trace. The second option down is 0. Okay, so it's going to ask me for my left bound. All right, left bound means what's a number on the left-hand side or to the left of our 0. Well, our 0 is about -1, right? It looks like. So a number on the left would be -3. All right, right bound, a number on the right would be, I'm going to use 0. 0. So what our calculator is doing, it's looking for a 0 between those two values, between those two numbers, between -3 and 0. We're giving it parameters to look. Okay, so now it asks me to guess. So you can either move your little spider guy, move the little spider by pressing left and right, not up and down. All right, you can move the Spider-Man around it or hover it over and press enter, or you can just guess. I'm going to guess -1. Well, I was wrong. It's -0.8. So if I had something like that, that tells me that I would have to use the quadratic formula. All right, so my first 0 is -0.828, comma 0. Okay, let's do that again to find this 0. Second, trace, 2, left bound. So here's my number over here. All right, so my left bound, I'm going to go 1, 2, 3, 4. I'll go 4, enter. My right bound, I'll go 7, enter. Guess a number in between these two, I'll guess 5, enter. My 0 was I was actually pretty close with 5, 4.828. 4.828, comma, 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 0. All right, let's try this last one here, an absolute value function. Okay, so here we go. I'll go up, deselect this one, and I'll go down. Now, if you want to find where the absolute value bars are in your calculator, you could press second 0, which is our catalog, and it's actually the first one there, absolute value, ABS. Okay, so let's go to my graph here. Boom, there's my function. All right, calculate the first 0. Second, trace. Wow, 0, 2. Left bound. So here it looks like, where is that? That's like that's about -1 or so. So I'll put my left bound at negative. I'll go -3 just to be safe. Okay, and then I'll put my right bound at 0. So remember, we're guessing in between these two, and I'm going to guess -1 again. Why not? Oh, look at that. It was actually -1. Good guess. Thank you. Hello. Thank you. No big deal. I'm just that cool. Okay, so now let's guess the other one. Second, trace, 2. Left bound, 1, 2, 3, 4. Let's go 3. Might as well. Right bound, 1, that's 3, 4, 5. I'll go 7 again like last time. Why not? And the 0 looks to be at maybe 5. Oh, wow. I'm so smart. There you go, 5, comma 0. It's almost like I've done this before. Maybe, probably, yeah, for sure. So that's how you find your zeros using your calculator, all right? And that's how you find zeros algebraically and graphically. Now you can go home on the weekends and talk to your friends about how to find zeros graphically and algebraically, all right? Or you can just go around at the dinner table maybe, or you can just walk down the hallway and pull out your calculator and show them, hey, this is how you find it graphically. That's pretty neat. All right, until next time.